Hi YouTube, Tim Eckert here. In this video I'm going to walk through some arithmetic sequence problems. So let's start with problem 1. Find the next term in the sequence. The sequence starts with 2 and then we have 5, then 8, and then so on. And we want to find that next term. So when we go from 2 to 5, we add 3 to 2. And then we go from 5 to 8, we're also adding 3. And this is called the common difference between terms. Sometimes they call that D, so if I was asking you what's the common difference, well, it's 3. Well, to find the next term after 8, we're going to add 3 again. So we add 3 again. 8 plus 3 is going to be 11. So the next term in the sequence is 11. Okay, let's keep going. Let's try another one of these. All right, next one, we're going to find the next term in the sequence. We have -4, -9, -14. So we're actually decreasing by 5. We're subtracting 5 to get to the next term in each of these. So if I take 14 and I subtract, or -14, subtract 5 from that, my next term is going to be -19. Did you get that one? Hopefully you did. All right, let's go to the next type of problem. All right, next one's a little bit more complicated. It says, write an explicit definition for the following arithmetic sequence. We have 4, then 11, then 18, and then find the 100th term of the sequence. So my explicit definition is going to be the nth term, a sub n, is going to equal the first term, a sub 1, plus n minus 1, where n is the number of the term, times the common difference. And the common difference is going to be 7, because when you go from 4 to 11, you add 7. So we're going to multiply by 7. So filling those in to find the 100th term, we're going to say a sub 100, the 100th term, equals 4, which is the first term, plus 100 minus 1, times 7. Now you're subtracting the 1 there because you're only going to add 7 99 times after the first term to get to the 100th term. So we're going to do 4 plus 99 times 7. So 99 times 7 is 693, so it's 4 plus 693. And that's going to be, our 100th term is going to be 697. So a sub 100 is going to equal 697. All right, let's keep going. Let's try another one. Write an explicit definition for the following arithmetic sequence. So 3, 0, -3. Then find the 1331st term in the sequence. Okay, so general formula here is going to be a sub n. It's going to equal the first term, so 3, plus n minus 1 times the common difference, which is going to be a -3 because we're decreasing by 3 each time when we go from the prior term to the current term. Okay, so we can say a sub 1331 equals 3 plus 1331 minus 1 times -3. Okay, so that's going to equal 3 plus 1330 times -3. So I'm going to take out my handy calculator here, do that out. So let's see here. We got 3 plus 1330 times negative 3. Okay, hold on one sec. 3 plus 1330 times negative 3 is going to be negative 3097. Or 987 rather. And that's the 1331st term. All right, let's keep going. All right, problem 5 here, if you're following along in my class, we're not doing 5 and 6 for tonight, but I'm going to run through it in this video nonetheless. So it says, write the recursive definition of the following arithmetic sequence, 19, 13, 7, and so on. Then find the fourth and the fifth terms using the recursive definition. Okay, so our recursive definition is going to be a sub n, the nth term, equals a sub n minus 1, which is the term before the nth term. And we're going to add the common difference. Now the common difference is we're subtracting 6, so we're going to add negative 6, or we just write minus 6. Now for the recursive definition here, we also want to list out the first term, a sub 1. Some literature you see a sub 0. That's going to be 19. So that's going to allow us to figure out what the sequence is. You have to have the definition here, the recursive formula, and then the first term. Okay, so the fourth and the fifth terms, we have the third term. So we're going to say a sub 4 is our fourth term. That's going to equal a sub 3, which is 7, minus 6. So a sub 4 is going to equal 1. A sub 5 is going to equal our fourth term, which is 1, minus 6. So that's going to be negative 5. Okay, hopefully that makes sense. Let's keep going and try another one. Okay, problem 6. Write the recursive definition of the following arithmetic sequence. So we have negative 10, negative 8. I wrote this wrong. The next term should be negative 6, not negative 7. Otherwise, it wouldn't be an arithmetic sequence. So negative 10, negative 8, negative 6. Then find the fourth, fifth, and sixth terms using the recursive definition to show your work. So we're going to say a sub n equals a sub n minus 1. And because we're decreasing negatively by 2, we're actually adding 2. So we're going to add 2 here. For our recursive definition, we'll include the first term. So a sub 1 is going to equal negative 10. Okay. And then let's find the fourth term. So we'll start with a sub 4. That's going to equal the third term, which is negative 6 plus 2. That's going to equal negative 4. A sub 5 is going to equal the fourth term, so negative 4 plus 2. That's going to equal negative 2. A sub 6 is going to equal the fifth term, negative 2 plus 2, which is going to be 0. Okay, so there we go. All right, let's try problem 7. Okay, 7 reads, find the missing term in the arithmetic sequence by finding the arithmetic mean. So we have to find the arithmetic mean between 2 and 14. Show your work. So I'm going to say AM for arithmetic mean equals 2 plus 14. And we're going to divide by 2. So 2 plus 14 is 16. And we'll divide by 2. That's going to be 8. Okay. All right. Let's keep going. All right. Problem 8. Last problem here. Same kind of thing. Find the missing term in the arithmetic sequence by finding the arithmetic mean. We have negative 3, an empty term, and negative 9. Show your work. So I'm going to say AM, the arithmetic mean, equals negative 3 plus negative 9 divided by 2. So that's negative 12 divided by 2, which is negative 6. So our missing term here is negative 6. And there we have it. Hopefully this video was helpful to you. If it was, please like and subscribe.